Good morning. So it's a pretty amazing place, huh? Okay. So I almost didn't make it down safely down the chute. I thought, oh, this is not good for the first speaker. So the image up front, essentially, I knew that I was going to be the crash test dummy today because you saw that all the debugging going on. Usually they put the dummy up front so that the rest of the speakers are safe. So today this is what I'm going to talk about. The title, as probably already know, Plumbing for Data Science. I'm Pradeep Gowda, as Calvin already introduced. I have been a IndiePy participant since 2008. So it's been a long association and fun association. Python itself, I've been a user and a developer in Python for since the last millennium. So that is not new to me. And also I organized the Data Science Indie meetup. So I see some familiar faces from there. So professionally, I work for Proofpoint. This is actually emerging threats that got acquired by Proofpoint just 2 months ago. You may or may not know about emerging threats. It's a local company, Indiana-based company that was acquired for $40 million a couple of months ago. So I'm part of the emerging threats team out of Indianapolis. We do internet security, email security. Specifically, my team does malware detection and tracking events, intrusion detection, things like that. So what we do constitutes as big data. And we use all the buzzwords, Hadoop, Scala, so all the buzzwords that you may have heard of. But I do think myself more as a plumber, because I know the whole data science thing is a buzzword. It's very attractive. It has gotten a lot of attention in the recent days. You hear about data science conferences. You hear about data science, new courses online. Even colleges offering programs. So it's a pretty hot topic. So this is the expectation. So top data scientists must be Don Draper in boardroom and Sheldon Cooper in server room. So when you have an expectation like that, you think, of course, it's very attractive position to be in. It's something cool to be doing, but the reality is more like, I still haven't mastered the Reveal.js. So this is more like the reality, the plumber. The interesting thing about plumbing is, without plumbing, it's not fun. You don't have to know that. It's very obvious, but it's not a very what you consider as an attractive thing to talk about, right? But if you look at, for instance, the data science, this is a very famous Venn diagram from Drew Conway from 2011. Essentially, he describes data science as intersection of 3 different skill sets or 3 different areas: hacking skills, math and statistics knowledge, and substantive expertise. So I compare this to hacking skills with, like, let's say a builder, a bricklayer. Okay, even you might think that is lowly, but at least it's like, well, it's not a plumber, right? Math and statistics, like a scientist. Okay, you have high ideas. You have a lot of theories and a lot of expertise in that area. And then substantive expertise where you're, let's say, dealing with security. So all about security and malware and virus and threats and all that. So, but where does the the plumber fit in? So I feel that is one area that sort of gets ignored. That's what I'm going to talk about today. So this is a very old image, actually from Oracle. So that should get the enterprise market out of the picture after the slide. You can see from the JPEG artifacts that it's a pretty old image, but it's still relevant. The process is still true for what you do in data science. even though the term has changed from data mining to data science. Of course, the scope is slightly different too. But the point is that it always starts with a problem definition, goes through data gathering and preparation, and then you go through your model building and evaluation. Most of the Kaggle computation, let's say you're familiar with Kaggle computation, you are really competing in this part of the the whole cycle. So the data is given to you, and then you apply your algorithms, you play with the data, and then you get results. So that's cool. But what comes before that is not really cool. I mean, once again, this is the enterprise part. I'm going to move off the enterprise slides to something more real. So this gives more credibility because it's handwritten. Actually, this is from the Columbia Data Science course, so this is a legit slide. Once again, if you see, they start with the clean data set. Okay, and then of course all the rest of the cool stuff, you can see there is machine learning and there is visualization, and then you build a data product and all the gizmos. But this is the the big elephant in the room. So how do we get there? So this is really the focus of my talk. We generate a lot of data from various domains, and then we collect a lot of data from various sources, whether it is email, logs, surveys, or other machine generated records and things like that, and then we process. So this is essentially the part that the plumbing comes in, and then the output of that is a series of tubes that get things in and get things out. Well, at least in our case, we hope that the stuff coming in is bad and the stuff going out is good. We don't want the other way. So also in the whole life cycle, I think of data plumbing not only as something that you do in the exploration phase. When you look at the life cycle, there is the exploration phase, and then there is the engineering phase. I think of engineering phase as really the big data space. That is, you convert what you discovered into actual production usage. That is when you have issues with scaling and being able to push out a product that is not error free but less errors, and that something that you can control. In the exploration phase, you are more open to experiments and errors and hypotheses. A commercialized product will not tolerate experimentation so much. So that is the engineering phase. But data plumbing underlies both stages. So I think we need a framework for thinking about this problem of getting good data in and presenting it to the users, or even if you are a data scientist yourself, that is, you are a person who does machine learning and productizing it, you are still left with the task of actually coming up with data sources, collecting them together, and coming out with the data that you can use. So we need a mental framework to think about that. I think we have to accept that working with data is messy. So this is not like putting up a new product. That is, you start with an IDE or VI or Emacs or whatever. You start with the blank slate, you know what needs to be done, and then you go from there. But real data is not like that. It comes in all shapes and forms. So this is messy. So first stage is to accept that it is so. And second thing is, once you step into this domain, you have to be language and tool agnostic. Even though we here today we are talking about Python specific tools and things like that, we'll see that you cannot be language dependent. You have to use whatever tools that are necessary and available and are expressive enough for it to use. That's the other framework that we have to keep in mind. And the third thing, maybe I'm betraying my Linux roots. I've been using Linux for close to 20 years in a year or so. So that may be betraying my Linux roots. But if you go and look at even in the introductory course to data science or any of the data engineering practices, you'll see that most of these lessons and best practices, they all assume that you are using a Unix-like system somewhere in your pipeline. I know that Azure is coming out with a lot of cool stuff, and you can do a lot of stuff with Visual Studio, but as of today, the Unix based platform is still way ahead of the game, and I don't see them slowing down anytime soon. So that is another thing that really had to get comfortable with, that you are going to deal with a lot of command line. So that's a link. I'll post the link at the end of the talk, but some of the blue lines are the actual links to some of the stuff I want you to read. That's actually from Neil Stephenson, the science fiction author. It's called In the Beginning Was the Command Line. So that's an interesting read. And the other thing is not just use the tools and all, but get familiar with the entire metaphor, Unix metaphor. That is things like pipe, filter, and composable programs, writing programs that do one thing really well. So these are some of the things that I think are going to be really useful when you're plumbing data. So what does the data landscape look like? So what is that we're dealing with? So we have a lot of data sources, starting from server logs that are completely machine generated. You'd be surprised how much trouble even machine generated data can give you. Right now, we are writing a parser basically to consume like 500 gigs of data that is generated over a span of 12 hours. And then, even in that is actually generated by a program, not by humans. But even that can have a lot of, edge cases that can trip you up. So machine generated data doesn't mean that it is, easy. It can be really hard. On sensors, this is from our experience. We talk about IDS, intrusion detection systems, and sensors and things like that. Once again, this is machine generated data, and then of course human generated. I don't have to. You have probably come across a lot of sentiment analysis algorithms and things like that, where people try to make sense of what are people saying about things. Let's say, what's your opinion about the Colts' first round draft? Yay or nay? So things like that. There is a lot of opinion, right? So how do you access that data and then get into your system? And then of course you have APIs that companies and products have made it open, and you expect them to be in a much better shape than the data that you scraped off, let's say an HTML page. That's another source which I didn't mention here, but there is a lot of data on the net in form of HTML and free form text and tables. So that's another source. Obviously, you have in-house data in the shape of RDBMS and all the newfangled databases, NoSQL, new SQL, not only SQL, whatever you call it. You have lots of databases. So some of the data formats that we are dealing with are something like JSON. JSON is especially popular for APIs and even XML, though that is reducing. I'm not saying that's actually a good thing overall. I may be a Luddite, but I think XML does, sometimes it does a better job of describing data than JSON, but nothing to take away from the usefulness of the shortcuts of JSON. Then of course, as I talked earlier, you have web scraping, the delimited files. This is probably the most, troubling formats that will come across. In the previous role, I dealt with data format that came from energy utility companies. So every single utility in the country probably has a different data format and slightly different from each other. Even though they are using upstream vendor, they're similar, but the output format is all different. So that can take a lot of time away from you. And then of course you have the binary data formats like Excel file and PDF. Which I was surprised to learn that some government organizations actually put out the data that you request in a form of, I think Catherine knows what I'm talking about. She works for F-18s, the federal government, so we can talk to her about why. So people actually give you data in PDF and expect you to use it. So, and of course you have this whole unstructured data which was not meant for machine usage, but then, everything is machine usable nowadays. So tools of the trade. We are continuing with the plumber theme, so duct tape, right? So we need to know what tools we are using. I was really surprised that when I was searching for Creative Commons licensed duct tape images, I was really surprised to see that there is scented duct tape. So what are the skill sets? Let's get down to the brass tacks. So what are the skill set we are looking at? I'm assuming that we are not coming from a developer background. We are assuming that you are coming maybe from some of the other backgrounds, like you are coming from math and statistics background, or you are coming from a domain expertise background, but you still need to deal with the stuff. So we assume that you have some basic programming ability. It doesn't need to be functional programming, doesn't need to be your object-oriented programming, whether it is C++ style or Smalltalk style. We don't really care about that. What we really care about is being able to describe what steps you need to take to parse the data or go through the data and output something. So that is the basic skill that we need. And we need some object-based thinking. I mean, not object-oriented, but object-based. That is, you're able to use some object and then do something with it. That's probably good enough. And of course, this all ties down to the fact that we are talking about Python, wherein you can do this kind of programming without getting deep into computer science or object-oriented principles. And then scripting. That is, you write a small program that is self-contained, and you're not building a framework. So the whole thing about Plumber is you're not architecting anything. Okay, you may think of this as quick and dirty, but it's more like, when do you call a plumber? A plumber is called in, of course, when you're building a new house, but more often than not, you're already pulled in to come into a house that is, it's already there and it has a problem, right? So you need to think in terms of quick solutions that can work. Text processing. I mean, if you hated grep, if you in your whatever previous encounter with it, get used to it. You're going to do a lot of it. Okay, so text processing is the other really important skill set that you'll have. And of course, most of the data that you want is not on your computer. So you have to learn to deal with whether it is mounting NFS drives or talking to a server over the internet, or talking to a internal API or RPC, a CoreBuff, I don't know. So you'll have to do that all. So you have to get familiar with how to use all of network-based services. And then obviously, a little bit of database programming, especially SQL. I know SQL is a little old-fashioned, but that is where most of the important data lives, even today. So what's in your toolkit? So that's the skill set we want to have, but what do we need to have? The belt chain. Actually, I don't really know what all Plumber carries with them, so but I assume they carry a lot of stuff. So command line tools, once again, I'm betraying my affinity to Unix. Programming languages, definitely, and of course, specifically here we are talking about Python, which is a good tool. I'll talk about later a little more. Data analysis tools, once you get past getting data and processing and cleaning and aggregating and things like that, you will want to do deeper analysis. That's what Neil is going to talk about after me. So PyData is a very good toolkit for that. Of course, you want to go a little more sciencey about it, statistics and maths, then you want to use R. So those are some good open source tools. Also language libraries. This is where Python wins a lot as of today, because it has library for almost anything that you can think of. Oh, that's my wife ringing. Okay. That's all right. So okay, I don't even know where my phone is. Sorry. Sorry. That's what integration gets you. Yeah. So, and also you should not be averse to using things like spreadsheets, because Excel can get you really far if you know what you're doing. If you're already familiar with Excel, I don't knock on it. I used to be like that, but I don't do that anymore because Excel can really do a lot of good stuff. LibreOffice, I use LibreOffice. So. Anyway, coming back to the language libraries, Python has a gamut of libraries that are really excellent. Then database query tools, once again, this can be a language library once again. So, but you need to know a bit of all this to be really productive. And then I keep talking about command line tools. So, what command line tools are really handy? Probably these few are really, the least you should probably know. wget, that allows you to download files. Curl does same thing, but with a different set of parameters. So for me, they are interchangeable. Some people like wget, some people like curl. So you may choose whatever works for you best. Okay, yay. grep. So as I said earlier, grep is really, really useful in any form, whether it is in the command line form or in a regular expression in your program. It's awesome. And then sort, basically it allows you to sort text in the command line. We'll probably see an example of this if you have enough time for the demo. So things like sed and awk, these are classic Unix tools. And some of the links are here. The Unix text processing book, that's by O'Reilly, that's available freely. That's a very good book. And then this link actually leads you to the one-page summary of all these tools. That probably is enough for you to get familiar with how to use it.
Well, you say those are links. We don't have access to those.
Oh, I'll upload the talk to the GitHub repository, EDPy GitHub repository, and I will share the link. So those are the some of the built-in operating system tools, but then those are not really meant for, well, not meant for, what I mean to say is those are very general purpose tools. But then as we use more and more JSON, we deal with more and more CSV files, we need tools that are specific to that use case. So some of the tools that I use daily, like JQ, which is JSON parser, that's really handy in the command line. And then CSV kit is another, incidentally, that is written in Python. So it's a really versatile tool. I really like CSV kit for a couple of reasons. One, what it does out of the box. The second is it's a really good library for it to study. You are learning to develop tools of your own, then CSV kit is probably one good tool that you will want to study because it does a lot of, it uses a lot of existing Python libraries. So it doesn't try to recreate everything from scratch. There are some tools which are single file scripts. They do amazing things, but then they're assuming that you don't have any package installed. They assume that all that you have is the standard Python library, which is pretty awesome, but that limits you to rewriting a lot of stuff that is already there in your code, which may be familiar to Windows users, because I don't know, for some reason Windows users have this issue of not being able to install. They're not familiar with that whole package concept. I know Windows 10 is coming out with package management, but even today the idea of installing packages is a little alien on the Windows platform. So a lot of people write standalone scripts. So CSV kit is a good code base for it to look at. So the demo time, I'll do that if I have time left at the end of the talk. So, but let's take a little detour here and see. So of course this is also a made up example, but this sounds very much plausible. That is, you have a short amount of time, you are given a data that you are not familiar with before, that is, it's some data that somebody came across, but it has useful information that you need to do something with in a short span of time again. So the problem is like this. So this is the JSON file. It has some information. All these names are made up. They are not really people's names. And then it has some information like name, email, city, Mac, that's your Mac address of the computer, timestamp, and then credit card number. So what is the problem? The problem, actually, you can go and see the challenge there. The link is there. So you have this data, but then you are told to inform some federal agency about this leak with all the names and the credit card numbers. But that federal agency only takes CSV files, as you can guess. Okay, they don't take fancy JSON files for whatever reason. So you have to convert this into a CSV file that the federal web application understands. So how do you do this? So if you go and look at the answer for this, people have written answers in all kinds of languages, of course, including Python. Okay, but I want to make just a point here, saying that it doesn't have to be a program. If you know how to do it, you can just do it using your editor. I mean, in fact, there is something called as a Vim Golf that basically challenges to do a certain thing on a text using the fewest number of keystrokes. Just like Perl Golf, there's Vim Golf. So I want to show something that I really like this example. That's the link. So somebody actually did that using just Sublime Text and multi-point editing. So no programming. So it's actually a GIF you can see. It's done. So the programmer in me would probably want to write a script. I can write a Python script probably in 10 lines to do the same thing, but then do I really have to write a program for it? I mean, the background always comes through. I mean, if you're a programmer, you always want to automate things, but sometimes you don't have to automate things. Probably you can just use your editor, or you can just use Excel. I mean, if it's something that loads into Excel and you can do some manipulation, go for it. So once again, the tool agnostic nature of things is important. So coming down to our dear and near language, Python. So why Python? So I would probably say community is the number one factor. So even though I no longer write as much Python as I used to before, I mostly write Scala and Pig and whatnot these days. So I still consider myself a Python programmer because it has been such an awesome community. I have been to a couple of PyCons and many PyOhio conferences, and of course many IndiePy meetups. The one thing that I really like about Python is the community. It's always been very welcoming and very accessible. And the thing about Python language itself is it's available. I mean, that it's available on Windows, Linux, Mac, whatever platform that you can think of. It's installed on most systems by default, except maybe Windows, unless you're using IBM laptop from whatever. So it is available for you if you want it, which is actually one of the big points in one of David Beasley's talk, how he wrote a program when he was made to pass through like gigabytes of data sitting in a room with no internet connection. Fortunately, he had a Python interpreter, and then he was able to do his job. I mean, that's a really fun talk. If you have not watched it, you should go and watch it on the PyCon videos. And then approachability, the reason why so many universities are switching to Python as their first programming language is the the approachability and the ease of with which you can teach people programming without getting too much into the weeds of why hash include and why what does void mean, and so things like that. And of course, it's multifaceted. There is no one typical Python programmer. It's not a web language. It's not just a web language. It is not just a statistics language. It is not just for doing desktops. It can do it all. You might say it doesn't do all of that well, but it's okay. It can do most of the things well most of the time. So that's what matters. It's a fair balance of expressiveness, power, and permissibility. That is, you get good expressiveness, but no, you don't go overboard. Like some languages allow you to really wrap yourself up in clever syntax. So Python doesn't allow that, so that's beneficial. And it's a team player. It doesn't really care whether you're running it on a JVM, you're running it on the bare metal C virtual machine, or it's Iron Python on the .NET. So it's a good team player on with most other systems. So what does Python come with? So these are the things that Python ships with out of the box. So we call this the batteries included philosophy. You have everything that you need without installing new stuff, which is a constraint for a lot of people. And also, I don't want to comment on the state of the Python packaging. It's not very pretty. So I think a lot of things can be done with just what we have in the standard library. So which is a lot. So these are some of the libraries that you'll really appreciate and use a lot when you do data processing, especially. So specifically things like string is very handy, and then process basically allows you to talk to external processes, spawn out new processes, and extract data from them and things like that. And then of course the operating system modules allow you to interact with the operating system. And there is a CSV module which is very handy if you are trying to do something very simple, but of course you may want to make your own custom libraries if you have custom data formats and things like that. Arg and OPD parse are handy if you are trying to convert your little script into something that is reusable by other people by passing in configuration or different parameters. So that's really handy for that. And then of course the JSON is really JSON and XML libraries are also very handy in parsing those data formats. And collections library is something that you should definitely look into if you're looking at large data objects and things like that. It's something powerful and helps you write cleaner programs. In fact, Calvin did talk about that in the last IndiePy meetup. So there are some of the third-party libraries that are really useful, like Request, the HTTP client, Beautiful Soup, Arrow, and SQL Alchemy. Of this, I would say Beautiful Soup is the one I have used a lot in the past that allows you to deal with all kinds of badly formatted HTML. So it's really, really handy. It's like a Sesame knife. That's handy. And then Request is a good library for not just for what it does, but also for the way you can humanize a library so that people can use it without worrying about the API too much. It sort of feels intuitive. That's a good library design. How do you install these packages? So, well, first I have to tell you how to install pip, but then I'll not go there. If assuming you have pip installed, you can just install things like this. Sorry. So text encoding is another area which is a huge headache if you're not dealt with it, especially in terms of Unicode and character encoding. So these are some of the things that come out of the box for you to deal with issues like that. And also the URL lib has some easy functions for you to deal with. How do you encode the URL when the URL looks funny? It's because it's encoded in a particular format. So how do you encode that and how do you decode that? So that comes in really handy when you're trying to parse URLs and see what parameters are being passed to the server. So let's say we have this piece of string. We know that this means something. Let's say this means the company Acme has a product with a bill of material number 1245 and it's in version 2. Okay, so we have this somewhere in the text file. So how do we get this out? So that's a typical regular expression problem. So we can describe this as a 4-letter identified followed by a dash, followed by a 4-digit number, followed by a colon, followed by another string. Of course, we can write a lot of if statements, nest it, and then we can parse it. But then you can also use a regular expression to do the same thing for you. So the line you see here essentially captures what I said here in a regular expression. So the /w curly braces 4 basically says it's a 4-letter identifier, and similarly you can see /d stands for digit, and then /w plus stands for, I don't really care for the length of the string as long as it is alphanumeric. If you have more complicated multi-line records, then you may want to look at PyParsing. It allows you to write a really nice parser without getting into the theory behind parsing and things like that. It's a pretty handy library. So other thing you'll be doing a lot of when you're parsing logs is parsing time. That is, this is where you come to hate time zones. Why? This is where you come to. So this is where a really good time library comes in handy, and then you will realize there is 5 time zones in Indiana, something like that. So there is, yeah. I mean, why? What were the thinking? And then why do you have daylight savings? I mean, I rant on that every year during the switchover, actually twice a year. So, because if you're a programmer, you will come to hate data in savings anyway. But all of this it's okay, but most of the time you'll end up searching for, so how do I parse a year? How do I parse a month? I mean, you forget all the flags. So somebody made a site just for that. All the site does is explain what each of these are. So bookmark this. I know this, it's always there in my browser, history. I never remember most of this anyway. This is a newer library in the mold of requests. You can see that this is much more humane, much more approachable than your standard time library. This does a lot of clever things like, you have a timestamp, you want to just decrement it by an hour. I want to get the timestamp for the last hour, that is 1 hour from that time. So this is much more intuitive than dealing with all the datetime objects and using time delta. In fact, that's what you will do if you are using the standard Python library. So this is much more humane. So request library I talked about. We can see that this does a excellent job of fetching data from. In fact, HTTP bin is another site you want to get familiar with if you want to learn how APIs work and how various HTTP codes work and things like that. We are using request as a third-party library and JSON that's inbuilt. We are getting some data from this URL, and then we are converting that into a JSON object, and then we are printing it. So this is literally 1, 2, 3, 4, 5 lines of code, 6. Okay. So you're basically downloading data, parsing it, and converting an object that you can use for other data manipulation. But get is mostly useful, but not as useful as being able to automate some of the data fetching by passing post parameters. So you can see the request does post really well. It's very simple. It's very intuitive. This is what really sold me on request, how easy it is to write a post request. I don't have to encode anything. I don't have to say that it's a multi-form, whatever. I don't have to worry about all that. So yeah, I talked about HTTP bin. HTTP Py is another library written in Python that is, maybe not. That's really handy when you're trying to test a API endpoint. So we'll not talk about much. I will not talk much about databases because it's a big topic. But think we have to remember is data comes in, data goes out. Who knows what happens, right? You can't explain that. So the simple message to all of you is SQL, learn it. There is no way out of it, okay? However, whoever is selling you MapReduce jobs written in JavaScript, no. I mean, you can learn that too, but learn SQL first. So I have only one recommendation for a database. You can guess it, it's PostgreSQL. Okay, so these are the few skills that you really want to pick up. I don't think you'll need much more than this if you're mostly dealing with, getting data out of databases and things like that. Select, where, joins, and know why and how to use indexing. Not all the intricacies of whether I should use a B-tree indexing or Gini indexing, whatever. You don't have to worry about all that, but you should know how to do at least these things. So things to remember when you're writing command line tools in Python is let the program do one thing really well. Don't try to do too many things. Make it configurable so that you can do different things based on what input it gets, and then make it so that it can take input from a configurable configuration file so that you can run it automatically even when you're not in front of the terminal. Like you want to run it on a cron job, so that's really handy. So these three things, if you keep in mind, you will automate a lot of stuff. So these are some of the libraries that you may want to remember. We'll skip this and go to the next. So there's a lot of Python libraries that we can talk about, but I think essentially the point is don't try to reinvent the wheel, and then use what's already there. And this book, the Bad Data book, is especially handy if you want to understand the lies and half-truths that are there in your data. So knowing what is bad data is probably as important as having a lot of data. And a lot of data doesn't mean that it's good. Okay, there can be a lot of untruths in that. I wanted to do a demo from this book, but you can actually go to his site. He takes you through a very nice example of using some of the tools I talked about, like JQ and CSV kit, to go from downloading data from New York Times all the way to multiple stages of converting it from XML, JSON, and all the juggling in one session, which is an excellent. It's like watching somebody do their work, which explains the number of tools that real people use in practice. And Python for Data Analysis, another book that has a few chapters on cleaning data and aggregating data and doing more things with that, apart from, of course, all the other cool stuff Neil is going to talk about. So, in summary, it is still programming. It is not something, it's not DevOps. It's magical, it's unicorn. It is still programming, okay, but your scale is probably slightly different, okay. Embrace the chaos. You can't predict what comes in through the pipes, okay, so you have to be ready for it. This is especially true when you're trying to productize it. You have to really, catch a lot of errors, okay, so you have to embrace that chaos. And then you have to remember that you're plumbing, you're not architecting, and you're not building, okay. You're building, of course, when you're doing the actual engineering rollout, but know the difference, okay. And then always document your steps, because you arrived at a data set, but you don't know what steps you took because you're just trying to get everything going. Well, no, you have to document everything, whether it's a make file or it's a text file, document it. Python is a very expressive language. Learn it and use it appropriately. Okay, thank you. This is my contact information if you want any information more about anything. The slides will be on the IndiePy's GitHub repo. I have not uploaded that yet because I don't know how to download the whole slide from the slides.com. So, but it will be there. Thank you.